So this, we say that covalent compounds, covalent molecules are sharing electrons, and the reason for that is because they don't form ions. So in ionic bonding, there's no sharing of electrons, there's merely the receiving and giving of electrons. The electrons will get given from one atom and given and received by the other. As a result, when you lose an electron, you become positive. When you gain an electron, you can become negative. So the person, the atom that gave the electron is now positive because it's lost one, and the one who received it is now negative. They then get attracted to one another. That's what ionic bonding does. It's not what happens in covalent bonding. And what happens in covalent bonding, it's usually between nonmetals. Between two. Covalent bonding is always between nonmetals, but occasionally nonmetals do form ionic bonds. But generally speaking, nonmetals will join together to form covalent bonds. They can't see, nonmetals would prefer to be negatively charged ions rather than positively charged, because it's easier for them. So if we go over to the periodic table, there's one here actually. All the nonmetals are on the right-hand side. So that means that they have a high group number. Okay. I mean, 3 doesn't sound that high, right? When you're thinking about it goes up to 8. But anyway, the point is it's higher group numbers. Okay, we won't talk about too much about the particularities, but essentially, the more electrons you have, the more full your shell is. It's going to be easier just to fill it up than it would be to try to empty it. So metals would rather empty their outside shell because they've got a small number of electrons in it, where non-metals refer to fill it up. So basically, it would make sense, wouldn't it, if you're halfway? Then if you're talking about a full outer shell, if you're talking about a shell that has 8 electrons in it, and you've got 4, then surely it's just as easy to gain or to lose electrons. So it does get a little bit confusing there. And to be honest with you, I'm not really sure what happened. Let's say, for example, carbon, what I'm pointing to now, carbon's in group 4, so it's got 4 electrons on the outside shell. I know it forms covalent bonds, but can you get it reacting with a metal to form an ionic bond? And if so, would that be a -4 ion? I'm not sure, to be honest. So clearly, somewhere the atoms around this boundary line, you won't really find many ionic compounds with them, because the nonmetals, that is, because they would have to form a very, very negative charge. But so we can look at the details of that later on. It's a good question. I'm not quite sure what would happen, but certainly covalent bonds are formed on general by nonmetals between two nonmetals, and it's when they it's because they would rather be negatively, if they formed an ion, they would be negatively charged, and so they wouldn't be attracted to each other then, because they'd be two negatively charged ions. And on top of that, if they both want to be negatively charged, they would have to both collect electrons from somewhere, whereas an ionic bond, one gives it to the other. So with covalent bonding, so basically what happens is, with covalent bonding, they don't form ions at all. Instead, they share them, and the atoms would rather have a full orbit. So what happens here is they orbit the entire molecule. That's what kind of happens. It doesn't really get that side of things doesn't really get talked about too much, but essentially that's what's going on. The electrons orbit the entire molecule. And to be fair, that isn't entirely accurate either, because when we say orbit, that's not really true. That's why we talk about shells. I'm going to stop the video at that point, because then that's getting into high level stuff. But the reason why we don't talk about orbits when we go higher up, when we talk about shells, is essentially because electrons don't really orbit in the same way like planets orbit stars. So I'll stop there.